a vector is a line in space. It has a magnitude, which is the length of the line, and it has a direction indicated by an arrow. If you see a vector drawn, it will always have an arrow pointing from start to finish. In order for us to work with the vector, it's useful if we can refer to it by name, and so we might use two capital letters, AB, but we can also use a small letter, U underline. Now, if I'm referring to the vector using the capital letters, I must have an arrow pointing from start to finish. AB equals U. So, here is a vector here. I'm going to call that DE. Now, what I'm going to do is to make DE the hypotenuse of a right angled triangle. And the reason I'm doing that is because I want to work out how we get from D to E. So if I start here at this point, how many boxes do I move in the x direction? So it's 1, 2, 3, 4, 5 in the positive x direction. I'm moving 5 right. 1, 2, 3, 4, 5, 6, 7. 7 in the positive y direction because I'm moving up. So what we can say then is that the vector DE has components 5, 7. So these are the components. That's the x component there on top and the y component on the bottom. Now this is what we call a column vector because the components are given one above the other. You'll notice that we don't have any lines separating the two numbers like this. It's not a fraction. So here's another vector. Now you'll notice that I'm just picking any point to start. There's the arrow pointing from start to finish. We should always have an arrow in a vector. I'm just going to call this, but I'm also going to use a small letter. So it's not unusual to see that on a vector diagram. What I want to do then is to work out the components of the vector. How do we get from the start of the vector to the finish? So we've got 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3. Now, it's 7 in the positive x because we're moving from left to right, but it's 3 in the negative y because we're moving 3 down. So, what I might do then is say the vector xy, which is also a, we've just got two names for this vector. We can use either one of them or both of them, has components 7, so 7 in the positive x, but 3 in the negative y. We're going down 3, so that's why we have a negative y component. So one last one of this sort. So here's a vector here. And I'm going to draw the line like that, but I'm going to put the arrow like so. And here, this vector just has a small letter p underlined. Now, what we want to do is to find the components of p. How do we get from start to finish? So it's 2 in the negative x direction because we're moving 2 to the left. And it's 1, 2, 3, 4, 5. It's 5 in the negative y direction because we're moving 5 down. So the vector p then has components -2, -5. Now, what if we start off with some information. So there's PQ, and it has components 3 minus 4. So we want to draw that vector. We can start any point on the page, give yourself plenty of space. Let's just start here. We'll start at this point, so it's 3 in the positive x, 1, 2, 3, and it's 4 in the negative y, so we're going to go down 4 spaces. So here is the finish point. The last thing we need to do is to draw a line connecting the two, and we should really label the vector PQ. What about the vector ST, which has components -6, 0. So let's pick a starting point. This is an easy one to draw. We'll pick a starting point here. Now, -6, the x component is -6, which means we move 6 to the left. And we have a y component of 0, which means we're neither moving up nor down. So here is the vector. The arrow always points from start to finish, so it's ST, like so. So what you could do now is go to the vectors booklet, page 109, exercise 13.2, and you could try questions 1 and 2. Check your answers and then move on with this video when you want to. So we've got two vectors. A is 4, 6 and B is -3, 2. And the first thing we're going to do is to add the two vectors together and see how that looks. So that's 4, 6 plus -3, 2. We add the x components together, so 4 plus -3 is 1 and 6 plus 2 is 8. That's us done the vector addition algebraically. And we can also do it diagrammatically, so let's pick a starting point. A is 4 to the right and 6 up, so 4 to the right and 6 up. Here is the vector A. Put in the arrow pointing from start to finish and label the vector. Now we're going to start drawing the second vector from where the first vector finished. And B is 3 to the left and 2 up, so if I count 3 to the left and then 2 up, there it is there. So the last thing to do is to draw in the vector B, the arrow indicating direction, and then we'll label it. What I'm also going to do is to remove this, and just to give me some space, here is A here. Now, we started our diagram at this point, we finished our diagram at this point, so I'm going to draw a line from start to finish, arrow indicating direction, and I'm going to label the vector A plus B. And if we just count the boxes, it's 1 to the right and 8 up. So the diagram and the algebraic calculation give us the same answer. Now what else can we do? We can multiply a vector. So what would 3a look like? Well, it would be 3 lots of 4, 6. That would give us components. 3 times 4 is 12, 3 times 6 is 18. I'm not going to draw this vector, you might want to. What would the vector minus 2b look like? Well, it's minus 2 lots of -3, 2. So minus 2 times -3 is 6, and minus 2 times 2 is -4. So let's see what happens. So here is the vector b, minus 3, 2. And if we draw 6 minus 4, what do we notice? We notice this vector is twice as long, but its direction is opposite to that of b. That's the effect of the negative. The negative changes the direction of the vector. Last thing to do. So why don't we, what would happen if we had 2a minus 4b? What would that give us? Nice simple calculation. I'm not going to do any drawing, so it's 2 lots of 4, 6 minus 4 lots of minus 3, 2. So 2 lots of 4 gives us 8. That's 8, 12 then. I'm just taking the 4 in, so 4 times minus 3 is minus 12, 4 times 2 is 8. 8 minus minus 12 is 20, and 12 take away 8 is 4. This is the last thing on this short lesson on vectors. Vector equation. What about something like this here? So 2 lots of x plus 3, 4 equals 7 minus 2. Well, I'm going to subtract this. Well, I'm going to subtract the vector 3, 4 from both sides. How will that look? I'm going to write it like so. So the 2x is going to remain unchanged. 7 minus 2 will remain unchanged. And there's the subtraction. And that's 3, 4. Now, 7 take away 3 is 4, minus 2 minus 4 is minus 6. And we're going to divide by 2 at the end, so x then has components 2 minus 3. And you can now try page 109, questions 4 to 6.